Hi everyone, how are you? Welcome to week 6 of Neon Dev Bootcamp. We're already at the second half of the bootcamp. Congratulations! I'm really happy that you're sticking with us, and in the next two videos we are going to look at a very different thing from what we looked before, which is a Solana Native SDK. It's a Neon EVM tool that allows to interact with Neon EVM using a Solana wallet. No MetaMask required. Previously, we learned how to connect to Solana programs from an EVM dApp using composability libraries. And now we are going to do the opposite, meaning that we are going to use Solana wallet, Solana keys to sign and submit Ethereum-style transactions and interact with EVM dApps directly from Solana without bridging assets or switching wallets. So today we'll unpack Solana Native SDK and see how to do simple operations like granting token spending approval or making a transfer from a Solana user to an EVM dApp using the ERC20 4SPL token we talked about before. So with Neon, you can use your existing EVM-based code to access Solana SPL tokens, as you already know, access the Solana user base, and interact with Solana's native programs using both Ethereum and Solana wallets. So first transaction flow is a very familiar route for Ethereum users, which we explored so far with composability libraries, where the user signs a transaction with their EVM wallet like MetaMask. The transaction is sent to Neon proxy, which acts like a standard Ethereum RPC endpoint. The Neon proxy translates the EVM transaction into a Solana compatible format with the help of the precompiles, and it handles things like gas metering, allocating the right Solana accounts, and making sure everything fits within Solana's runtime constraints. Then this fully formed Solana transaction carrying the original EVM logic is submitted to the Solana network, where it immediately gets picked up by the Neon EVM program and executed like it would be on Ethereum, but only on Solana. And Solana Native SDK allows to make this second transaction flow possible through Neon EVM as well. So a Solana user signs a Solana native transaction using a wallet like Phantom. That transaction already includes the EVM execution data, so it bypasses the Neon proxy entirely. It goes straight to the Neon EVM program, where the EVM bytecode is executed just like before. So the user flow for this is very simple, and Neon is completely abstracted away from the user. The user connects with a Solana wallet to an EVM app. The user executes his transaction directly in his Solana wallet and pays the gas fees with Sol. The transaction is executed directly in Solana, and the user can check his transaction in, for example, Neon Block Explorer. So today we are going to look how this transaction goes through, looking at two simple example scripts. First for granting token approval, and the second for making a transfer. So first, for the approval, we are going to approve USDC tokens for ourselves using a Solana wallet. This is just to showcase that scheduling a transaction with Neon EVM is possible from a Solana wallet, and this is the simplest script possible, so that you can take it and use it as a template, for example, for more complicated scripts later on. So for this script, you'll only need a Solana address. That's why in your env file, define your Solana private key. And you don't need to define any other keys this time. Here for Neon RPC, we must use the /sol endpoint. This is a special RPC endpoint specifically designed to support scheduling transactions. This includes some additional functionalities compared to the standard endpoint, and this kind of transaction won't work if you don't use the /sol RPC. So make sure to use it in this kind of script. Now we are going to load our Solana wallet and initialize the user in the SDK. So that we have two key addresses, a Solana wallet address for signing, which is Solana user.public key, and the Ethereum compatible wallet derived from Solana key. Also, here we are going to check whether the Solana wallet has enough sol, and if not, the script is going to warn you that you need to add sol. So make sure to fund your wallet in advance or get the warning and just know what to do. So then we do a check to confirm that the approval value changes after scheduling and executing the transaction, because basically what we are going to do is we are going to do two checks. In the first check, we are going to see if the USDC has already been approved from the user, and then we'll recheck later to confirm the approval worked so now we create and send a scheduled approval transaction. First, we get the current transaction count with a nonce for the Neon EVM wallet. We are getting it before building the scheduled transaction so that we can identify each transaction and execute them in the correct order. Then we construct the EVM transaction to call the approve function on the USDC contract, and this schedules an approval from the Neon wallet to itself using a random value. Here we use a timestamp. And so again, this is intentionally simple to showcase contract interaction via a scheduled Solana transaction. There is no transfer yet, just approval logic, but then here we are going to add transfer logic and see how it goes. Now here we also need to get gas estimation. Solana needs to pre-approve the resources required to run the transaction on Neon. Then we package the transaction, gas info and nonce into a scheduled transaction object, which will be later signed and sent to Solana for execution. And this is the primary data structure used to schedule and relay EVM logic via Solana. Now, this method, getAccountInfo, is very important. It checks if the balance account exists for Neon wallet. And if it doesn't, then this account must be created explicitly. So if the balance account doesn't exist, we trigger the create account instruction, because without this account, the transaction will fail due to missing infrastructure. Then we sign the transaction using the Solana wallet, and we send the transaction and wait for it to come through. On DevNet, it's a bit longer at the moment than on mainnet. That's why we also add a 60-second timeout. Then here we query the Neon RPC to get the EVM transaction hash using the wallet and nonce, because when scheduling via Solana, you don't know the EVM transaction hash upfront. This call retrieves it after execution. And then we log the finalized EVM transaction hash. So we finally are going to be able to update the USDC approval value post-transaction to confirm that the scheduled transaction worked, and we were able to grant approval for spending USDC from Solana user in the EVM contract. So, and as you can see here, when I'm running the script, so here in the script that I've been running, you can see that, so here in the script that I ran, you can see how the approval value is increased every time I run it. which means that this kind of transaction is able to go through from a Solana wallet. And now that we proved it's possible, we can go to a more complicated transaction, which is a transfer transaction. Now here in this script, we are going to transfer USDC using a Solana wallet. And again, without MetaMask or bridging or anything else. So again, this works thanks to the ERC-24 SPL standard, which supports Solana native spending by checking delegation. And actually, we recently upgraded the ERC-24 SPL contract to make a more Solana native experience and enable spendings from Solana wallet to the contract that integrated this ERC-24 SPL. So in the contract interface, we have a get Solana ATA method, which checks Solana ATA has granted approval. And this address is derived from Solana public key, so that the contract treats this user as a Solana native user. So going forward, we check if the Solana user's ATA associated token account has granted approval to the Neon PDA, granted delegation. And if not, we add this delegation or approval instruction from the ATA to the PDA. The script, as you can see, is very similar to the approval script we saw just now. Only here we are building the transaction call data with a transfer of 1 USDC. And the transfer logic is going to include a sender, which is going to be a Solana user ATA, a receiver, a random Neon wallet, and an amount, which is in this case 1 USDC. So the script is going to check for SOL and USDC balances, and it's going to verify delegation. If it doesn't exist, an approve instruction will be included. The PDA is calculated from the USDC contract address and the Neon program. You must provide the ATA owner, which is a Solana user, and the amount to do this. Then we are going to just send the transaction as before, and in the first run the delegation won't exist, so the approval will be included, and in the second run the delegation will have already exist and the approval will be skipped. So when we run the script, this is what we are going to see. And we are also going to watch the balances, as for the standard USDC balance is going to decrease by 1, and the receiver's USDC is going to increase by 1. This basically proves that Solana ATA to Neon ERC-20 transfer has occurred and was entirely signed and scheduled from Solana wallet. And again, the script uses the same skeleton as we used in the approve script. You can compare the two and see that there is actually just a building transaction call data for transfer included here, and the delegation from Solana's user USDC ATA to the PDA contract of USDC for the approval. So we are gonna get the balance address if it's missing, and then add instruction to create it with create balance account instruction, and then we just submit the scheduled transaction to Solana. We'll schedule it, we'll wait for 60 seconds, and then again we get the transaction hash and the sender and the receiver's balances. So to recap, here what we did, we approved and transferred USDC using only a Solana wallet. We also saw how to schedule and sign EVM transactions from Solana, and we used ERC-24 SPL to enable true Solana native interaction with Solidity contracts. So this time your task is very simple. Run the scripts I've shown you and see what happens and how it happens. The goal here is to learn how Solana Native SDK allows us to send transactions from a Solana wallet to an EVM contract, so that next time when we go into practical integration of Solana Native SDK into a swap dApp, you can already understand what's happening behind the scenes, and you'll be able just to work on the integration. So to submit this simple task, create your own GitHub repo with the scripts. You can simply copy them and run them. You don't need to write your own scripts to submit these tasks, but it's always good to play around with the code. It will give you more practice as usual. Thank you so much for your time. I'll see you next time.